Cool. All right. All right, so we're gonna get going. How's everybody doing today? So excited to have you all with us. I'm Sari Custer, Chief Science and Curiosity Officer for Arizona Science Center, and I am so excited to have you guys join us for today's virtual chat with NASA, all about Artemis. So the Artemis program, working on getting the first woman and the next man to the moon by 2024, a big ambitious goal. And we've got a very special guest, Lora Bleacher from NASA. She's going to be with us today, and we'll introduce her in just a second. We're officially going to go over those rules one more time before we launch into today's program. So if you're just joining us, I know we had a few people just join us now. We're going to participate using the chat on the right to communicate with all the attendees. We cannot see you. So if you're waving to get our attention, we can't see you. If you're trying to speak to us, we can't hear you. So you're muted and your video is blocked. You can only see the speakers and hopefully hear us. But if you have a question today, use the Q&A function at the bottom of your screen. That's the little chat bubble that has a Q&A, sort of near where you have your mute button or your video on off button, or where it would normally be at the bottom of the screen. So click the Q&A and type your questions in there. If you're joining us from one of our camps and you're in a group setting today, you're going to use the instructor in the room to help communicate your questions to us through the Q&A function. So awesome. We've got lots of folks here in the chat. Please, this is also a reminder to be respectful of our community while you're in the chat today. So no spamming the chat. I don't want to have to jump in there. We want to make sure that everybody's being super respectful, asking good questions, and putting those questions in the chat or the Q&A chat. All right. So with that aside, let's get going. Again, I'm so super excited to be able to talk about this. It's such exciting work going on in the realm of space science. So Lora, thank you for joining us today. We really appreciate having you here. Quick intro, Lora Bleacher is the Artemis Communications Lead at NASA Goddard Space Flight Center. She works closely with Goddard scientists, technologists, and engineers to share the excitement of their contributions to NASA's Artemis program with the public and other stakeholders. So she received a master's degree in geological sciences from Arizona State University. So we've got a local connection here. And Lora did some work on meteorites, museum studies, and then also, if I recall, Lunar Reconnaissance Orbiter and International Observe the Moon Night. So that's also something near and dear to our heart because it's operated right here in Arizona. So Lora, I'm going to turn it over to you to share a little bit more about yourself and then also about the Artemis program. Thank you again for joining us.
Right. Well, thank you for having me. I'm so happy to be here to talk with you guys. I will go ahead and share my screen because I actually do have a little bit more information about myself. So let me get that up. Yeah, so I'm so happy to be here. A little bit about me. I do have an Arizona connection, as was just mentioned. So I actually got my graduate degree, my Master of Science, with a focus on geology and planetary science and meteorites at Arizona State University. I actually was raised in North Carolina, so I got my undergraduate degree in geology at North Carolina State University. And Arizona was really good to me. I happened to meet my husband there. He also went to Arizona State for graduate school. He also studied planetary geology and now also works for NASA. So I've got a couple pictures in here of us. So over on the left, that's actually us doing some field work together in Hawaii. I know we had someone, at least a couple people on from Hawaii, so that's exciting. And you know, we've gotten to do all sorts of fun things. So the picture in the middle is I'm standing beside Jack Schmitt, who was the only geologist to ever walk on the moon, one of the astronauts for Apollo 17. So the last mission that sent people to the moon almost 50 years ago now. And you know, now you know, in my time at Goddard Space Flight Center, which is located in Greenbelt, Maryland, you know, I not only get to do great things at the center, but I also get to travel around, interact with people around the country. The picture right below the NASA logo there is a picture of me and a couple other scientists and also my husband down in South Carolina for the 2017 total solar eclipse. So we got to help with a big event at a baseball stadium there, which was a lot of fun. And then the picture on the lower right is also another picture from Hawaii. But we do have 2 kids, and occasionally we get to get our kids involved as well, which is a lot of fun, and get them outdoors with us and involved in a lot of things. So NASA is a great place to work. I've had a really wonderful career. and now is a really exciting time within NASA, or an extra exciting time, because it's actually always exciting, but it's even more exciting now because we do have the Artemis program, which, as you have probably heard a little bit about already, is going to return astronauts to the lunar surface by 2024, including the first woman to the surface. So we're really, really excited about that. And when astronauts land on the surface, they're going to be going to a place on the moon that we have never been before, which is the moon's south pole. And I'll talk a little bit about why that is and why we're excited about it as we move forward in the slides. And then the overall goal with our Artemis program is to eventually send people to Mars. That's the next era of exploration. But by first sending people to the moon, all of the preparation, the testing, the hardware, everything that has to go into that, into developing a sustainable long-term presence at the moon, that will help us by serving as a stepping stone, if you will, to help us understand how we can do the same thing for Mars. So, as we've already talked about, we did have the Apollo missions in the past. We also have had robotic missions to the moon. And so this is the list of lunar science missions to date. So you can see that our exploration of the moon with missions began in 1962 with the Ranger lander. And then since then, we've had other landers, we've had orbiters, we had the crewed Apollo missions, for example. And then since Apollo, we've had other missions that have primarily been focused on science. So helping us better understand the moon, how it formed, how it got to look the way that it is today, how it even could be changing today, where there are resources. And so we've had a pretty robust period of exploration and science since the Apollo era. But you can see that the last mission that we sent was in 2013. And again, the last time we sent people was almost 50 years ago. So it's time to go back, and we're very excited to do so. One of the big things that we were able to get from the Apollo program, of course, when we sent people to the moon, were lunar samples, actual samples of rocks, of dust. And those samples have told us quite a bit. We know that the moon is very old. We know that it formed pretty soon after our solar system formed and the Earth formed. We actually think that the moon most likely formed as a result of an impact with the early Earth. We also have realized since the Apollo program that the moon has water. Now, it doesn't have lakes or oceans like we have here on Earth or rivers, but it has water ice, we think, trapped in very cold regions, permanently shadowed regions, especially at the poles of the moon, places that don't see sunlight. And I'll talk about that in another minute. We've also learned a lot about impact cratering. So if you've ever looked at the moon through a telescope or with a pair of binoculars, I'm sure you have seen those round features that are all over the moon. Those are impact craters made when asteroids and comets even hit the moon at different times in its past. A lot of that occurred earlier on in the first couple of billion years or so of the moon's history, but we know that impacts are still happening today, just on a smaller scale. And some of the missions one of the missions we have in orbit right now, the Lunar Reconnaissance orbiter, has actually, since it's been in orbit in the last 11 years, has actually taken pictures of the same places over and over and has seen these new impact craters forming just since it's been in orbit. We've also learned a lot thanks to samples with our about volcanic activity on the moon. Those dark areas that you see when you look at the moon in the sky, those are actually areas that are primarily the rock type called basalt. So that's a rock type that forms from cold lava flows. And then again, we know that the moon probably formed soon after the Earth formed. And when the moon first formed, it was originally molten and then actually separated into layers, just like we have layers on the Earth with the core mantle and crust. But as you can see with the picture down on the lower right, we've got modern work going on these samples as well. So we're still learning things from them. We're still opening and analyzing samples from the Apollo missions that have never been analyzed before. So they still have a lot of secrets to tell us, And every time we do analyses of this data coming back from our landers or our orbiters or from these samples, we're learning new things about the moon, but we're also generating more questions. There are more things that we want to learn. And so being able to go forward to the moon again with Artemis is really going to help us answer even more questions and probably come up with a few more. So as I mentioned, right now I'm at Goddard Space Flight Center, which is one of the NASA centers around the country. We happen to have our primary location, our primary campus, or headquarters, if you will, in Greenbelt, Maryland. So I'm coming to you today from nearby where I live in Annapolis, Maryland. We also have sites located in different states. We've got a site in Virginia, West Virginia, Texas, New Mexico, and we're actually the nation's largest organization of science and technologists dedicated to the study of space. And so we do a lot of work in a lot of different areas. We build and operate spacecraft and send them all over the universe. We build telescopes, or excuse me, the solar system. We build telescopes that help us look out into the universe. And we're helping to support NASA's plans for Artemis in a lot of different ways. And I'm not going to go into a huge amount of detail on some of these. There's one that I will talk about more specifically in a few moments, which is the Lunar Reconnaissance Orbiter. But again, we're doing a lot to help NASA prepare for Artemis, and we're really excited to be able to do so. All right, so the Lunar Reconnaissance Orbiter. So this is a mission that it's in orbit around the moon right now. It's been in orbit since 2009, so we just hit the 11-year anniversary. It was built at Goddard Space Flight Center, and it's also being operated from there today. That's where the mission has its Mission Operations Center. The spacecraft has a variety of science instruments on it, including the camera, the Lunar Reconnaissance Orbiter camera, or LROC as we call it, which is actually operated from Arizona State University. So Arizona plays a big role in our current exploration of the moon. And not only has the Lunar Reconnaissance Orbiter been telling us about the moon, but it's also helping us to prepare for going forward or back to the moon with Artemis. So one of the things that the Lunar Reconnaissance Orbiter has been able to give us is a really detailed map of the moon's topography. So when I say topography, I mean the highs or lows, the elevation of the surface. So in this image that you see right now on the screen, we've used colors to show us the topography or the elevation in different areas. So the cooler colors that you see, like the blues and purples, those are the lower areas. And the warmer colors, like the reds and oranges going up to white, those are your higher elevation areas, so more mountainous areas. So one thing you're probably noticing is that there's kind of this really big, kind of roundish area down near the moon's south pole that looks like it's lower in elevation. It's got those cool kind of blue and purple colors. And in fact, we think that this is actually a large impact basin, and we call it the South Polar Aitken Basin. And it's very deep, and that's one of the reasons that we want to explore there and send people there with Artemis. We haven't been there before, and we think that we'll be able to actually collect samples of the moon from a different location that are going to sample a different time period from the moon's formation, and possibly give us some samples from below the crust, more in the mantle of the moon. So that will be really exciting. We also, thanks to the camera that I talked about earlier, get these really great high-resolution images of the moon. So we can actually see things on the surface of the moon with the camera that are about the size of a suitcase. This particular image is a much larger feature though. So this is actually a mountain, or what we call a central peak within Tycho crater, which is one of the bright craters that you can actually see on the near side of the moon, the side of the moon that faces the Earth. And to give you a sense of scale, I have this yellow line here pointing to the top of that peak, and you can see there's a little boulder there. And then the image in the upper right is a zoom in on that boulder. That boulder is the size of a baseball stadium. So, so that just gives you kind of a sense of scale. But because we're able to see things at so many different scales with these images, because they're so high resolution, and we can see things from the size of a football, or excuse me, a baseball stadium all the way down to a suitcase, we can generate these really great, detailed, high resolution maps of the entire lunar surface. Both the near side that faces the Earth, and then the far side, which is the side that always faces away, that we can only see with by visiting it with spacecraft. And so for reference, if you look at the near side picture there, down near the bottom, I'm not sure if you guys can actually see my cursor or not, but there's a really bright crater that has these really long rays generating, kind of going away from it. That is Tycho crater. So that picture I just showed you of the mountain with the big giant stadium-sized boulder is in the center of that crater right there. So with our orbiters, we're able to get these really great views of the entire surface, collect all of this great data, and LRO has certainly been helpful with that. But you know, we can take a lot of this data and put it together, though, which is nice, and that's what this visualization has done. But what this is also showing you, though, are the location of the Apollo landing sites. So again, Apollo was the only program that we had that actually sent crews to the surface of the moon. And you'll see as we go through this that all of the Apollo landing sites, so the only places we've sent people, are just on the near side of the moon and around the moon's equator. And so in a way, if you think about it, yes, we've been to the moon a few times, but we haven't really explored a whole lot of it. It would be like if you were visiting the United States for the first time and you wanted to learn as much as you could about the entire country, but you could only pick a couple of places to visit within a certain, you know, kind of plane. You probably wouldn't learn as much as you could about the entire United States as if you were able to go to multiple places. So we're excited again that Artemis is going to allow us to visit some other locations on the moon. And then another thing that will be really great with Artemis is that we're going to be able to explore farther. And so what this is an image of the Intrepid Air and Sea Museum in New York City. And then this yellow thing that you see on it is where one of our scientists at Goddard actually mapped out the traverse, or the area that the Apollo astronauts explored after landing. And so you can see they really were not able to explore very far. So in the early Apollo missions, we didn't have a lunar rover. We didn't spend a lot of time on the surface. And so for another sense of scale for this, you could see this kind of aircraft up here on the left. You know, we barely walked a distance farther than the length of that aircraft with Apollo 11. Now, when we got to Apollo 17, we were able to go farther. So again, Apollo 17 was the last time we sent people to the moon. This is also a picture of this is a picture of the New York City area, and you can see this little yellow oval up here in the top is the Intrepid Air and Space Museum. And then again, our same scientist put down an overlay of the multiple traverses that the Apollo 17 astronauts were able to take because they were on the surface longer. And you can see that they were able to travel a farther distance, right? And they went farther than our other Apollo missions. However, they didn't even make it out of New York City, you know? So we should have greater capability with Artemis to be able to land in some different places. And as we build up our infrastructure and our architecture over time, we should be able to explore farther than we ever have before. So what are we going to do on the moon? I just mentioned, you know, we're going to explore. Well, what are we going to be doing when we send people back to the moon? Well, we're going to be doing new lunar science. We're going to be exploring farther. We're going to be trying to better understand resources on the moon. So, you know, how can we get to and make use of that water ice that I mentioned? Can we bring back new samples of new rock types that will give us more information about the moon, how it formed, and how it has changed to be the way that it is today? We can also better understand the history of the sun, for example, by looking at solar particles that have been trapped within rocks on the lunar surface. So there's a lot of really valuable science that is still left to do, and Artemis will help us do that. Another thing that we can do with the moon is use it as a platform to study the rest of the universe. So when we're on the moon, especially when you're on the far side of the moon that faces away from the Earth, the moon helps block radio waves. And so it helps give us a clearer view of the universe than we're able to have. Plus, we don't have the atmosphere that we have here on Earth that we have to look through. So there's a lot of value in going back to the moon, continuing to explore it, continuing to ask and then answer new questions. And so again, you can see our science objectives here. We're going to be doing a lot of field geology. This time around, we are going to have rovers accessible to us that will be able to take us farther. We may have some rovers that are crewed such that people will drive them, as well as some that are robotic and will almost serve as robotic assistants to us as we explore in different areas. Again, the ability to collect new samples, to access regions that we've never been to before, especially these really cold regions at the South Pole. And then one thing that we did with Apollo that we hope to be able to continue to do with Artemis is to install new science instruments to help us collect new data, to monitor conditions at the moon and how they may change over time. So just a lot of great science. So the South Pole of the moon, again, this is our target for where we want to land people in 2024. And one of the reasons, as I mentioned, that we want to do this is because we think that there's water ice that is trapped within these permanently shadowed regions at the poles. So I'm not sure how well you guys can see this, but this is a globe of the moon. This is the near side that always faces Earth. And then, of course, we have the North Pole and the South Pole, which is where we hope to land our astronauts in 2024. So unlike the Earth, the moon does not have much of a tilt on its axis. And so you've got sunlight that just kind of skims right across the tops of these really deep craters. So some of them at the poles don't ever see sunlight at all. Their rims around them may be tall enough that they see sunlight all the time, but their insides may actually be dark all the time. And it's those cold, dark areas that we think may have water ice that, of course, we can use as a resource for humans to drink. We can separate the water into its hydrogen and oxygen components and use those for different purposes. So being able to find that water ice is really important. Another example of the scale that we're talking about in terms of exploration of the South Pole. So this is an image of a couple of craters at the South Pole. That one there with the map, the overlay, is Shackleton Crater. Shackleton, as you can see there, is about 3 times deeper and wider than the Grand Canyon. So I know most of you are from Arizona and you may have visited the Grand Canyon before. I'm sure you've seen pictures of it. Well, that gives you kind of a sense of scale about what we're talking about. You know, it looks like a fairly small crater when you look over here to the one on the left, but in actuality, you know, this one feature is 3 times deeper and wider than the Grand Canyon. And this is the type of area that we want to explore. So when we start getting pictures back from the landing on the moon in 2024 and beyond with Artemis, it'll look pretty different than the images that we got back with the Apollo astronauts. So it should be pretty exciting. All right, so yes, we want to land at the South Pole, but the other thing that we may be able to do with Artemis and with some of the missions that we're partnering with commercial industry and companies on is also be able to visit some other high priority landing sites. So what goes into picking a landing site? So access to sunlight. That was one of the reasons that, that we landed at the equator with the Apollo missions, was we were able to have this continuous sunlight during a 2-week lunar day. Direct to Earth communication. So, you know, being able to see the Earth and communicate directly is really important. You know, if we're not able to see the Earth, we're on a side of the moon that's not facing the Earth, then we're going to have to rely on other hardware or satellites to help us communicate. So the more direct to Earth communication that we can do, the better for the astronauts to be able to communicate with us quickly and easily. We also want to make sure that we pick areas to land that are safe. They're easy to land on. You know, they're not going to be very rough and strewn with boulders. They're not going to have a really steep slope. They're going to be more on the flat side. And then again, access to permanently shadowed regions so that we can get these volatiles or these, you know, water ices and resources that will be useful for us. So with our industry partners, we are planning, in addition to the crewed missions of Artemis, to also send some uncrewed robotic landers. And we call this our Commercial Lunar Payload Services, or CLPS program. And these companies that we're partnering with are going to be helping to deliver scientific instruments to the surface. And they'll have the ability to, you know, take a look at the characteristics I just mentioned on the last slide for high priority landing sites. And we hopefully will be able to visit some different locations on the moon. So these missions are going to be starting in the next couple of years. So even before we have that first crewed landing in 2024, and they're going to be doing a variety of science, as well as helping us understand. Some of them will be going to the South Pole region, and so of course they'll be able to help us better understand what the site will be like there for the crewed landing that we'll do in 2024. All right, so preparing to go. So we just talked a lot about, well, why do we want to go and what might we do there? Well, how are we actually going to get there? So right now, NASA is building and testing the Space Launch System, which will be the highest ever payload mass and volume capable rocket that we have ever used to send humans and cargo into space. And it will be able to eventually travel into deep space. It'll go farther and faster than ever before. And it really will be the backbone of our future of human exploration. So to give you a sense for what it can do and the scale, I have to look at my notes here and make sure I can remember all of this. It's 322 feet tall. So you can see it's bigger than the space shuttle, right? A little bit taller than the Statue of Liberty, if you're familiar with that and have seen pictures or visited New York City. You can see here that there's actually 2 space launch systems shown. So one that we'll use for Artemis 1, and then one that we'll use for Artemis 2, and I'll talk about the differences between those in a minute. So the SLS system for Artemis 2 will be a little bigger. And you can see that with the SLS system for Artemis 2, that we actually will be close to the size, just about 1 foot taller than the Saturn V rocket, which was used to deliver the Apollo astronauts to the moon. So what can we carry in terms of payload? What is our capability? Well, we will actually have enough power, enough thrust to be able to hoist 154,000 pounds to low Earth orbit. That's about 12 full-grown elephants. And then, of course, we'll need additional power to get from low Earth orbit. Oops, let's see. Good old update notification from NASA. I'm going to try and move that off the screen. Sorry about that. And then I'm going to try and ignore it, and hopefully we'll continue with the presentation. And then when it comes to getting us out of low Earth orbit into the moon's orbit, we'll have enough thrust, enough power to take about 57,000 pounds with us. So the SLS will definitely be a workhorse for us and allow us to carry more mass into space and to go farther than we've ever had the capability to do before. All right, let's see here. Okay, good. I can ignore the warning for that update for the moment. All right, so as I mentioned, we are in the process of building and testing the Space Launch System. This is an image from our Marshall Space Flight Center in Alabama, where we are in the process of conducting what we call green run testing. So what is green run testing? So green refers to the fact that we are testing hardware and technologies that we have not used before, that are not flight proven. And the run just means we're testing them all in sequence. So we're testing pieces, we're testing a piece, you know, kind of putting it together with other pieces, testing bigger and bigger and bigger components of our system so that we can be as sure as we can of the success and the safety of the system when we go to launch it into space for real. So those tests started earlier this year, actually took a little bit of a pause over the last few months with the pandemic that's been going on, but we are in the process of getting that testing back up and running. So stay tuned for news and video of that. Should be pretty exciting. And then next I'm going to talk about the Orion spacecraft. So this is the vehicle that will actually carry the crew to space. So it will provide emergency abort capability, it will be their home while they're traveling, and it will also be the vehicle that they use to safely re-enter Earth's atmosphere. And you can see some of the progress that we've made on Orion. So right now, the Orion spacecraft is at Kennedy Space Center in Florida, where it is awaiting, or it's undergoing testing and awaiting its eventual integration with the Space Launch System rocket. So some of the cool things about the Orion capsule are that it will be able to better accommodate astronauts of all sizes. So earlier in NASA's history, because of the hardware that we had available and the spacesuits we had available, astronauts kind of fit within a certain size range. Well, we're all people. We know that we come in all different shapes and sizes, and that's not exactly realistic. Well, Orion will be able to accommodate comfortably astronauts that are as small as 4 feet 10 inches tall up to 6 feet 5 inches tall. And then Orion's crew module is going to provide about 30% more cubic volume of space than the Apollo capsule that was what took astronauts to the moon the last time we visited. Orion's heat shield will withstand temperatures of about 4,000 degrees during re-entry, which is about twice the temperature of Hawaiian lava. And then as Orion enters Earth's atmosphere from a mission to the moon, its heat shield must protect us from the temperatures that will be generated during that re-entry period. And we expect those temperatures to get up to about 4,900 degrees Fahrenheit possibly. And just for reference, the surface temperature of the sun is about 10,000 degrees Fahrenheit. So it's a pretty sophisticated system, which should do a great job at keeping our astronauts safe during re-entry. All right. So Kennedy Space Center is, our gateway to launching astronauts into space from U.S. soil. Many of you probably just saw the successful launch we did a couple weeks ago with our commercial crew program. That was from Kennedy and was exciting to watch. And our Artemis missions are also going to be launching from Kennedy, or KSC as we call it, in Florida. And so we're having to develop some new capabilities, new hardware to help us manage the launch of the Space Launch System in Orion. One of those is a mobile launcher that will be able to move the Space Launch System rocket and Orion from where they are put together in the what we call the integration facility at KSC out to the launch pad. So even developing this type of hardware and all of that testing that goes along with it, it's also taking place and making progress. All right, so preparing for Artemis 1. So Artemis 1 will be the first integrated flight test of the Orion spacecraft and the Space Launch System, or SLS, from Kennedy. So this first voyage will actually not have crew. So what we're going to be doing there is pushing the system, testing it to its limits to make sure that the rocket is going to be prepared to safely send astronauts into orbit and then bring them back. So we are working hard to prepare. Right now, we are hoping maybe for a launch in the late 2021 timeframe. We will have to see how that goes. At the same time, we are, and when we do the Artemis 1 launch, we're also going to be launching a series of, or releasing a series of CubeSats. that are going to be doing some really cool science as we go past the moon and back to Earth. So that will also be something that Artemis 1 will help us with. And some of those CubeSats are also going to be focused on helping us better understand resources like water that we can hopefully make use of with our future Artemis missions. And now, yep, hopefully this video will play and you guys can hear it. Yeah, so as you can see, there's a lot of steps that we have to test when we launch Artemis 1, but we have full confidence that everything will go well and that will lead us to Artemis 2. So Artemis 2, we're going to pretty much do something similar, but we're going to have people on board. And so Artemis 2 is actually going to take people farther before into space than we have ever sent people before. So Artemis will go out and around the moon and come back. But when it goes out around the moon, it's going to do that at a much farther distance than we ever orbited the moon with Apollo. So it'll be a great test of the system. It will be amazing to get the perspectives of the astronauts and their reactions to going that far out into space and past the moon, since it's been so long since we have been able to do that with people. And so it will be really amazing. And then, of course, Artemis 3 in 2024 is when we will be landing the first woman and the next man on the moon. So there's a lot of excitement coming up quickly over the next few years, and we are so excited to share it with the public and with the commercial industry. So one of the things that we're doing to prepare for landing people on the moon is we're actually working with private companies, with industry companies, to help us figure out some of the best ways to actually build the landing craft, or what we call the human landing system, that will take astronauts from orbit of the moon, from the Orion spacecraft that they'll use to get up into space, and how they will then get from there down to the lunar surface. And so NASA just recently selected 3 companies that it's working with right now to come up with some designs for what that human landing system could look like. And you can see the names of those companies there. One of them may be familiar to you. It's SpaceX, which again was just involved in the commercial crew program launch that we just had. But it's going to be really fun to see the designs that they come up with. You can see these drawings here, which are some of their initial concepts. And then early this coming year, 2021, NASA is supposed to be selecting which 1 or 2 of these companies that it plans to work with to help prepare the landing system for 2024. Another thing that we're doing is we're building what we're calling a gateway, which is essentially a space station around the moon. So you're probably familiar with the International Space Station, which is celebrating its 20th year in operation this year. It's been a great platform for international partnerships, for science, for helping us understand how people can live long-term in space. But we're going to be doing something similar around the moon that will help serve as a point as we build the sustainable architecture around the moon, that astronauts can live and work for periods of time while they're in transit, and that can also help give us eventually kind of a jumping off point for sending people to Mars as well. And so you can see some of the same international partners that we work with for the International Space Station and Earth orbit, we're also going to be working with for the Gateway in lunar orbit as well. And when we get to the moon, again, we're going to stay. This is, our plan is to build up the architecture, the hardware, the resources, the rovers, the habitation modules that will help us be able to hopefully visit at least once per year. Send a new crewed mission up at least once per year and help us continue to better understand the moon and help us practice using the processes, the technology, the hardware that will take us to Mars eventually. One of those things that we're working on right now as well that will help us be able to explore the moon with this new era of Artemis are new spacesuits. So these suits are actually called XEMUs, that's our acronym, which stands for Exploration Extravehicular Mobility Unit. So these spacesuits are going to offer improved mobility and function for our astronauts. As you can see here in this artist drawing of what astronauts might be doing on the moon in 2024, giving them greater flexibility than our Apollo astronauts had so that they can bend and collect samples and do the work they need to do, while also, of course, staying comfortable and staying safe. So we'll be testing this new spacesuit design on the International Space Station starting in 2023 to prepare us again and make sure that we will be ready to use these when we land on the moon's surface in 2024. And then all of this is to help prepare us for taking the next giant leap to Mars. So this is a picture, I believe, from our Curiosity rover looking at the night sky from Mars, and you can see that little pale blue dot there is the Earth. And so everything that we're doing right now is to eventually help us take that next giant leap. And we know that there's a lot of work we still have to do. We know that there are some hazards involved with human spaceflight in terms of understanding how the sun can affect us, understanding how people just handle being away from home for a very long time, the effects of microgravity for long periods of time. But we're prepared to meet those challenges. We're working on them now, and we have no doubt that we can do it. We have a lot of different careers that are all working towards this goal within NASA. There's a lot of opportunity if you're interested. One way to get your foot in the door is to start as a NASA intern. So we have interns ranging from high school age up through college that work with us for a few weeks at a time during all parts of the school year to work hand in hand with our NASA employees. And they're actively contributing and are going to be helping us get to the moon in 2024 and develop a sustainable presence just as much as our long-term employees. So NASA is a great place to work. We're ready to go, and we hope that you guys come along with us. And I also want to give a quick shout out before questions for International Observe the Moon Night, which is September 26th this year. So wherever you are, however things are like where you are at that time, you know, get outside, you know, on your patio, in your backyard, your driveway, and look up at the moon and just pause and take a minute to observe it with the rest of the world. And with that, I will take questions.
Awesome. Laura, that was fantastic. Thank you so much for sharing. And it's amazing just to hear how we're taking that next giant leap into the future of human space exploration. And admittedly, my husband's gonna be really happy to hear about the expansions on that Orion capsule because he's well over 6'6", you know, even though it's not for him, he went to space camp and he just liked to know that that possibility will be there one day.
Right.
So we have a ton of questions and there was so much good information. I didn't interrupt, so they're sort of in no particular order, but there was one recent one
Okay.
that I want to start with. When do we have any dates when Artemis is scheduled to launch specifically? We've got a year, but do we know when in 2024 we might look to launch?
So yeah, we don't have the timeline within 2024 nailed down quite yet, but rest assured that when we have that date picked, we will make sure it is widely announced.
So, and actually, I'm going to stop sharing your screen so we can see you a little bit better here too. Let me actually, here we go.
I can stop sharing it.
No, that's okay. There we go. We got you. All right. So, as I said, in no particular order, going to the suits, there's a question about how much oxygen astronaut suits need or can contain. And I know you're looking at some new advancements.
You know, that is actually a great question that I don't actually know the answer to what that number is. You know, we do want astronauts to be able to have enough oxygen to go out and do the work that they need to do. It takes a lot of effort to get into and out of the suit. There's a lot of testing that has to be done. When you're on the surface of the moon, the surface is very dusty. So there will also be some housekeeping that needs to be done to help keep the suits clean and in shape for future uses. And so there will definitely be enough oxygen to give them the time to stay out for these long EVAs that they need to complete their...
Oh no, did we lose you? Uh-oh. Hello? Did we lose everybody?
Screen is frozen.
Oh, we hear you again, Laura.
Screen froze for a minute, so if you asked another question, I missed it.
Nope, that's okay. I think we got most of the question about, I had a moment there, I couldn't tell if it was you or me, and I had a panic, but no, we got most of that question. So it sounds like there's still a lot of work to do, but a lot of exciting work that's going to be made possible by all of the new advancements on those suits with oxygen. Not that they didn't have them before, but advancements.
Right.
Okay, so will people ever live on the moon and how would they get there?
Oh, great question. Well, you know, again, with the Artemis program, what we're trying to do is enable us to have a longer term presence on the moon with our astronauts. You know, I would love to see it. I mean, I think now, especially with the fact that we're getting all of these commercial companies involved and helping us with space flight, developing technology and hardware and spacecraft, rockets, to take us into low Earth orbit and then to take us all the way to the moon eventually and help us land on the moon. I think it will happen at some point. I just don't know when, but I think there will be an opportunity to eventually purchase flights with companies into Earth orbit and to stay on the moon for short periods of time. I would love a vacation on the moon.
Me too, actually. I would go. I would totally go. Type it in the comments if you would go to the moon, if you had the opportunity. I'm curious to know. Okay, so we have some of our campers on site that have a specific question, and they want to know how many people have already been to the moon.
Oh, well, that's a great question. Yeah, so for each of our Apollo missions, we sent 3 people into space, 1 person orbited, and then we sent 2 down to the surface. So 12 people have walked on the moon.
And there's a couple of questions in here about, do we know who that first woman and next man will be on the moon?
We do not right now. So NASA will probably announce that. I don't know. I'm guessing maybe in the next year or so. We are all curious about it. The astronauts are very curious about it. You know, but the astronauts are so amazing. They're all so well qualified. And I know that they also are going to be super excited to support whoever does get picked to go. So it'll be really interesting to find out who, but we don't know yet, and we don't know when that announcement will be.
Thank you. I can imagine that is going to be a huge announcement. Do we know how many robots have been on, oh, it says on Mars. I thought it was going to be the moon, but how many robots have been on Mars and prep for our human missions there?
So that is a really good question as well. I don't know the number off the top of my head. I probably should. I can tell you that we are actually getting ready to send something new to Mars. So I'm not sure if you've heard about it, but on July 20th, so just in a couple of weeks, we're going to be sending a new rover to Mars called the Perseverance rover. And so Perseverance will be doing some interesting science, of course, as well as for the first time, it will actually be collecting samples that we intend to store so that we can have a future mission pick those samples up and hopefully bring them back to Earth. So right now, the only samples we have from Mars are meteorites, but we would love to actually be able to hand pick samples to bring back, and that is what the Perseverance rover, one of the things it will be helping us do. Yep, and thank you for that. I think, Patricia, if you pulled that up. So 25 days from now, July 20th, is when we'll be sending that next rover to Mars. So definitely be on the lookout for the launch coverage of that.
I feel a watch party coming on, so that's
yes, that would be awesome.
Okay, we've got another great question here. What are the landmarks of progress that need to be hit before Artemis is ready to go? So before we send the next folks to the moon, is there certain technology or goals that we want to meet or hit? And then, you know, what kinds of steps do we need to take before that mission's ready? So great question.
Yes, it is a great question. And, you know, as you probably saw, especially with the video I showed, which is kind of like our, you know, an artist concept of all the different parts of the Artemis 1 mission. All of that hardware, you know, it's being built, it's being tested, the procedures are being mapped out and tested. There's a lot of steps we have to take, you know. When we think about going from Artemis 1 to then Artemis 2 with people, and then eventually Artemis 3 with humans, you know, when you add humans in, they're the most fragile part of this whole system. So there's going to be a lot of training that the astronauts are going to have to do. So, you know, the training that they undergo right now for going into space and learning how to work in microgravity, because they'll have that type of environment when they're traveling to the moon, all the way to then thinking about working in the low gravity, so not microgravity, but lower gravity on the moon's surface. So there'll be training involved with that. There'll be a lot of geology training that they'll have to undergo, training in the new spacesuits. So there's a lot of different milestones that do need to be hit. We've already hit a lot. We've got a lot more we have to hit, but I'm confident that, that we'll be able to do it.
Again, it's so incredible to think about all that work happening. And is there something, it's a good question, I'm trying to tie it in here. Is there a golden ticket or a discovery from a geological perspective that you're really hoping is going to be addressed by the research and what we learn on the moon?
Yeah, so with Artemis 3, when we land in that South Pole Aitken Basin at the moon, if we are able to bring back a representative sample of what we think the moon's mantle may have been like, that will be so telling and give us so much information about, you know, not just the moon and how it formed, but also potentially about the early Earth. It will really help, again, as I mentioned earlier, not just answer questions, but also provide new questions for us to answer in the future. And then also, if we're able to you know, identify, access this water ice that we think is in these permanently shadowed regions, thinking about the composition of that ice, or testing and analyzing the composition of that water ice will help us understand the source of it. We have a lot of different ideas for how the water ice got there. Was it delivered by a comet? Could some of it have been produced through interaction of energy from the sun with the surface of the moon. And then some people think that the water molecules have kind of hopped around and then kind of gotten trapped in these cold regions. So there's so many questions that we'll be able to answer, and then new science that will be enabled. So those are the types of samples, the 2 samples that I'm hoping we'll get.
Thank you. And let me see, again, we still have a ton of questions, folks, and we're going to respect our time frame here. So forgive me, I'm going to end with a couple here. How did you get your job at NASA? Is one of the questions from one of our young viewers today.
Great. Well, that's a great question. And thank you for asking, or thank you for all the questions, but I am glad to have a chance to talk about that one. So I mentioned earlier in the presentation about the importance or the value that interns bring to NASA. So I was also a NASA intern. So I worked as an intern at Johnson Space Center, and that really, introduced me to a lot of different people within NASA, to the culture of NASA, to how the centers function and operate. And then when I went to graduate school to get a degree focused in planetary geology, I was then able to, maintain some of those connections. My husband actually did the same thing. So we're both members of what you could call, I guess, the NASA pipeline. And so he was an intern at Goddard Space Flight Center, where we both are now, and then continued to maintain those connections, continued to work with a lot of people, do research, and come back for, multiple summers. And then when we both were ready to make the leap into our careers and working full time, we already kind of had, again, our foot in the door. So if you are interested in working for NASA, focus on science, STEM, engineering, math, and if you can get internships, then I highly recommend that you do it. And thank you for putting up the website there. It's an easy URL to remember, intern.nasa.gov.
That's fantastic. So thank you for those career tips. For any of you who are looking to continue to get inspired in space science, here's your connection, your easy way to get your foot in the door at NASA. And of course, you can always explore your curiosity more at Arizona Science Center as well. So Laura, thank you so much for the great presentation today, for sharing more about the Artemis program. And we hope to have you back to talk more about it here as we get closer and closer to it.
That would be great. Thank you so much for having me. I really appreciate it. I hope everyone takes care. And yeah, stay tuned on social media and nasa.gov, our website, and follow along with us. So it should be really exciting.
Excellent. Well, thank you again. And for those of you who did ask, I know there were several questions about can you get a copy of this recording? We'll be posting it on our YouTube channel, and we will share it via social media after this recording has ended. So check back with us soon. For those of you looking for a little more space information as well, you can always check out azscience.org to schedule your guided experience with us today. One of our new guided experiences is Stellar Space Science, where we do talk about space. We get to see the stars during any time of the day in our Dorrance Planetarium, build a lander, check out all kinds of information that are hands-on, including crater activities and so much more. So by all means, check us out, and we can't wait to see you next time. Thank you so much for joining us today. Take care, everybody. Thanks again, Laura.
Thank you. Take care.